Okay, so we looked at graphs of linear equations, and the graphs of linear equations are lines. And we had some of the lines kind of going diagonally up and to the right, and we had some lines kind of going diagonal down and to the right. So these lines going up and to the right and down to the right, um, that direction of going up and to the right and down to the right, we call that slope. So we're going to talk about the slope of a line in this section. So what is the slope of a line? So to create a mental picture of slope, imagine a car driving over a hill. First, the car drives up the hill, which would be this part. Then the car drives down the hill, down the other side. Now think of the spatial distances the car moves in an XY coordinate system. Think of vertical movement as a rise. So as the car is going up the hill, it's moving vertically, it's moving higher. Okay, that's considered rise. And horizontal movement, meaning it's traveling up the slope or across the slope, that's horizontal movement, and that's what we call run. So from any one point, we have a positive run to the left, or I'm sorry, a positive one to the right, and a negative run to the left. And that corresponds with positive values being to the right and negative values of x being to the left. And then we also have positive and negative rises. So a positive rise correlates to positive values of y, and a negative rise correlates to negative values of y. So even though our car is moving in a diagonal line, we could think of diagonal movement. Okay, so we can think of diagonal movement as having a vertical component, which is the rise, and a horizontal component, which is the run. So as this car is going up the hill, it has a vertical component, which is the rise, and a horizontal component, which is the run. So think of the slope of the car's path being the same as the slope of the hill it is on. And so let me make one more comment before we leave this picture. So on the left-hand side with the car going up the slope, you'll see that it's traveling to the right. So it's traveling in positive values of x. And it's also going upward. Its elevation is increasing. And so that's going to be positive values of y. Now, the car on the other side of the hill that's going down, okay, so it's going down and to the right. So it's moving to the right. That'd be positive values of x. That's positive values of the run. But now it's descending, it's going down. Okay, so now that's going to be going in negative values of y, or a negative rise. Okay, so try and keep that image in your mind. So as the car drives uphill, the car has a positive rise and a positive run. Okay, that's just actually what I was just talking about. So as it moves up the hill, it has a positive rise and a positive run. The car, therefore, has a positive slope. So we use lowercase m as a variable for slope. So this has a positive slope going uphill. The car's direction is up and to the right. Up and to the right. Sorry. Driving downhill, the car has a negative rise. Okay, so going down the hill, it is a negative rise and a positive run. Negative rise, positive run. The car, therefore, has a negative slope. So the slope is negative going down and to the right. So the car's direction is down and to the right. And so, how did we determine that this has a positive slope? So a positive slope is the ratio of rise over run. So when we have a positive rise and a positive run, we're going to get a positive slope. Let's see if I can guess this. There we go. So we have a positive rise and a positive run. We're going to have a positive slope. And when we have a negative rise with a positive run, a negative and a positive produces a negative. So now let's match this analogy of a car driving up a hill, a positive slope, and downhill with a negative slope with lines on an XY plane. So you can see we've got an X and a Y axis, and we've got 4 different lines. And we've got each of these 4 different lines has their own slope. And so you can see the slope of line 1 is rather steep. So this is a positive slope because it's going up and to the right. Line 2 also has a positive slope because it is going up and to the right, just like our car did going up the hill. Line 3 is going up and to the right, and line 4 is going up and to the right. So all of these lines have positive slopes. If we look at the dashed lines on the Cartesian coordinate plane on the right-hand side, you'll see that all of these lines have negative slopes. So line 5 has a negative slope because it's going down and to the right, just like our car, down and to the right. Line 6 is going down and to the right, and line 7 is going down and to the right. So you can see it has a negative slope. So some observations about these lines. Number 1 is that the slopes of all these lines are all positive slopes. These line graphs are going up and to the right. However, their slopes are not equal. So if you imagine you were running up a hill, okay, I think you would agree, if you're running up a hill that was this steep, you would find that a lot more strenuous than running up a hill that was that steep. So the slopes of these different lines are unequal. And this is another way of saying it, okay? These slopes are all unequal. And in fact, the steeper slope is this higher slope, okay? It's going to have the greatest magnitude. So it's the greatest in size. The next greatest is the second line. The third greatest is the third line. And then the smallest, the line with the smallest slope, is the one that's the shallowest. And that's the one down here at the bottom. Okay, and that's just kind of what I just talked about. I'm sorry for my throat here. Okay, now here on the right-hand side, so lines 5, 6, and 7, they all have negative slopes. They all go down and to the right. All of their slopes are unequal. This is another way of saying that they're unequal. Line 5 has the steepest slope. Okay, so that was this one. This has the steepest, highest magnitude slope. Line 6 is the next lowest, and line 7 is the lowest. It has a gradual descent. So, as we have seen, the slope of a line can be positive or negative, but the slope of a line can also be 0 or undefined. So a horizontal line is an example of a line with 0 slope. So as you can see, it doesn't rise. Okay, it doesn't go up at all. It only runs. So it has a rise of 0, but it has a run that's not 0. Okay, it's a run of of anything else. And so when we think of slope of this line, line number 8, it has a rise of 0 and a run of some number. And so that's just going to be 0 divided by a number. And so that gives us a slope of 0. So all horizontal lines will have a slope of 0. Now, what about a vertical line, like line number 9? So this has a rise that is not 0, but it does have a run that is 0. So remember, a run goes side to side. And this is a line that does not have any horizontal component to it. It's strictly vertical. And when we think of slope as being rise over run, and if the run is 0, well, we can't divide by 0. So dividing by 0 means that the slope of a vertical line will be undefined, always. So the short definition of slope here is that it's rise over run. The rise is the vertical change all over the run, which is horizontal change. And we can calculate vertical change by calculating a difference in y coordinates. And we can calculate horizontal change by calculating a difference in x coordinates.